2.4. Now we're going to begin solving equations with variables on both sides. And this is where you start separating the babies from the adults here, because this is the beginning of setting up things and you actually using this for math. You will use this for the rest of the time that you're in high school, depending on what class you're in, no matter if it's geometry or what. You have this ability to do multiple step problems with variables on both sides, and at any kind of difficulty level, you will be successful in math. We're going to be starting out with a smaller, not so complicated problem, but the rule of thumb is to get all your variables on one side, all the terms on without the variables on another. Most people prefer to have those variables on the left, and let's get into a habit at first of doing them on the left until we're really, really good at it, and then it doesn't matter. This is where making that wall that we've been talking about is super helpful. It doesn't matter which side, but variables need to be on a different side from the ones that don't have variables. And this will involve several steps. If you are one of those kind of people that need room to work, please use paper. Do not try to cram it all into a little B space on a piece of paper, and do not try to do it all in your head. It will only create problems, and you get your problems wrong, you get bad grades, and you won't like that. So I am going to take this problem and write it on another screen so we have plenty of room. All right, this is 5x plus 2 is equal to 2x plus 14. Now these problems, this one's a very simple one, will become more and more complicated because I'm going to be giving you multiple steps on one side with distributing, with combining like terms, with a lot of fractions. So just know that's coming down the road. Let's make that wall, and you'll notice that we have side A with 5x plus 2, side B with 2x plus 14. At this point, you can choose where you want to start, okay, because you've got variables and everything on both sides. I tend to want to put my variables first together. So over here is 2x. I want to move it over to the side where 5x is. Right now that 2 is positive. If I subtract it from this side, because that will undo this over here, then I have to subtract it from this side. And notice how I am putting it underneath the like terms. If you do not keep these things straight, you'll mess things up. So over here, 2x take away 2x, or 2 trucks take away 2 trucks is gone. That just leaves me over here with 14, okay, which is what we want for now. All right, now over here, remember, it's always addition. 5x plus minus 2x, or 5 minus 2x, whichever way you need to look at it, whichever way helps you to do it right. That makes 3x. Now, this plus 2 hasn't been messed with yet. We just dragged it down because we haven't done anything with it yet. So now we have this problem, which is now a one variable problem. Okay, so that's what you want to get to first, get it down to one variable. All right, so now we have 3x plus 2 equals 14. I want to get rid of the 2 first by subtracting it, because that is the opposite of positive 2. Okay, remember plus or negative, whatever you need to do. This 2 goes underneath the 14. They're like terms. There's no x's over here. 14 plus a negative 2 will make 12. Or 14 minus 2, whichever way you want to look at it. These go away. Then you just bring down what you haven't done. Now it's a very simple problem. 3x equal to 12. That's multiplication 3 times x. So I divide by 3. And I get x to be 1 over here and 4 over here. And now it is solved, and x by itself, and it's positive. We can take this x as 4, and if you want to check our work, we must go back up, and everywhere there is an x, it has to be plugged in into the original equation. So I'm going to put it over here in red. 5, and where I plug in, you'll see me use parentheses because I want you to see what I'm doing. I suggest you do that too, get really good at it. You don't have to do it much. Alright, so I want to know if this side is equal to this side. That is what I want to know. If it is, if these are equal, then I've done it right. 5 times 4 is 20. 20 plus 2 is 22. Is that equal? 2. 2 times 4 is 8. 8 plus 14 is 22. Yes, I did it right. So the answer is 4. Okay, so you're going to want to check your work. You want to make sure you keep all things straight and keep it nice and neat. Do not try to cram it on your papers. And if you need to, get another piece of paper. Really simple. All right, let's do another one. 10x plus 12. 2 times 5x plus 6. I know I'm not going to remember this. You see what that was. That's what happens when you get old. Can't remember. 10x plus 12. 2 times 5x plus 6. Alright, so now we have variables on both sides. We have our wall, okay, but we also have parentheses. And as you know, PennDOT says, we've got to get rid of those parentheses. This means getting rid of the parentheses by distributing. 2 times 5x makes 10x. And then 2 times 6 is positive 12. That going to be 10x. Oops, I have a hard time writing. All right, what do you notice already? Does anybody notice anything weird? I have 10x plus 12 is equal to 10x plus 12. The same exact thing on both sides. Okay, if this ever happens and you have the same exact thing on both sides, what that's going to mean is when you solve for your variable, the variables are all going to go away. Okay, that means that all real numbers work because any number I put in there will make it true. This is a true statement without being checked. This is a true statement because this equals this. So that means that all real numbers work. Okay, that means infinitely many answers. But if I wanted to work this problem, let me write it down here. 10x plus 12. Come on, right? If I subtract 10x, that's gone. If I subtract 10x, that's gone. That leaves me writing 12 equals 12. Then you got the true statement, and therefore all real numbers work. So that means any number I plug in for x on one side and plug that same number on the other side, any number will work. It doesn't matter if it's a negative 1,000,000, 2,000, or whatever, it will work. Okay, so that is one of the scenarios that you might have as an all real answer. Okay, let's go back. Then we have this one, which is one we just talked about. This one right here, where it's 9m minus 4 equals negative 3m plus 5 plus 12m. Clean up over here, put those like terms together. Negative 3 plus 12 make a positive 9m. Alright, so now when we subtract 9m from both sides, the m's are gone, and you end up with this problem. Is that a true statement? This is false. That is never going to happen that will be true because negative 4 does not equal 5. Alright, so if it's a false statement, that gives us a no solution answer. So you could have solutions that are be one solution where you've actually solved it and it's like x equals 4. Or you can get infinitely many solutions where the statement is true on both sides, like this one right here. All right, that one's infinitely many. Or you can, or all real, the same thing. All real rules. Or you can get one that's a no solution, like this one where it is false. Okay? So those are the three choices you may run into in this section. So just be aware if that happens and your variables go away completely, then you're either going to have infinitely many or no solution if the variables are all gone. All right, I believe that's all that's on this video. If you have questions, this will take a little bit of practice, but that's what I'm here for. Come see me in the morning. See you then.